Cool. So first of all, welcome everyone to the very first Melbourne Microsoft Automation meetup. So Venera and I have been talking about this for a while, and we wanted to kind of get a meetup going that's focused purely on the automation side of Azure and DevOps. So well, with all this COVID and all this stuff going on, we thought it's finally a good time to kick this off while we have time on our hands. So let's get started. Right. So first one is announcements. So we'll go through, I'm not going to go through everything that's happened in the last couple of weeks, but I've picked out, I think, about 5 or 6 things that I thought were interesting in the world of Azure in the last couple of weeks. So the first one was the rules engine coming into Azure Front Door. Azure Front Door came into the ecosystem probably about 2 years ago, I think. In almost this weird sort of space, because we had application gateway, which did lots of your WAF and your routing, but that was regional. And then you had traffic manager, which you used for routing traffic between regions. And then you had Azure CDN, which did your acceleration and your caching. And Front Door kind of came in half doing all of those things. So it took over failover from traffic manager. It did bring in acceleration using edge locations, and then they brought in WAF into it, but you still couldn't do proper rules. So until this announcement, we were very much using a combination of Front Door and application gateway to actually do proper, WAF routing, CDN, acceleration. So what they brought in is the rules engine into Front Door that lets you map and match rules and conditions based on headers and paths, and also do things like cache control. So I think that's quite interesting, and a potential candidate now if you're running a combination of Front Door and application gateway, to see if you can actually replace application gateway using just a single Front Door instance across your regions. The next one was the Spot instances going into GA in Azure. So Spot instances had been there on AWS for a long time. What it effectively allowed you to do was to buy or effectively bid on instances where sorry, I'm going to drop this one off. Give me a sec.
Beauty of having kids, I guess.
She's fine if she's going to be there, but when she starts singing, I'm guessing you can't hear anything else on the other end. Sorry. So Spot instance general availability on Azure is very interesting, because it's been there on AWS for a long time. What it lets you do is to bid at a lower price than an on-demand instance. So generally, it starts from about 25%, and then goes up onto the on-demand price. So if you want to run a batch job, or you don't really care if the VM terminates, you can bid on a Spot instance and you get charged up to the maximum rate of your bid. Especially if you're doing things like batch processing, lots of data science work, you can you can use this solution to do that. It's stateless. So when you can trigger a machine that comes up, it'll run for as long as your bid is there, and then it terminates. Very good for things like data processing, AI, ML solutions. Right, the next one is Blob Index. This again, I think AWS has kind of had it for a bit, not necessarily at this level, but blob storage is great. You can store all sorts of blobs in there, but the limitation with blob storage is that you can only retrieve a blob based on the name. So for example, if I had 1,000 pictures of different people taken at different locations. And I had to have some sort of search criteria. The only way currently would be to include that in the blob's name. And if I wanted to store metadata about that, I would have to put that in table storage or something like that, and then have some form of mapping and a function that put those in and retrieve them. What what Blob Index allows us to do is to effectively create tags against blobs. So in that example of having, a 10,000 photographs of people, you could then tag each of those blobs with maybe the person's name, where it was taken, and some other sort of context. And then you can search based on that. So you can go, hey Azure, give me all the blobs that are this particular person. So I think it's a pretty cool feature that's just come out in the Blob engine. Next one was the snapshots for Azure Files going into GA. So currently we relied on, if Azure File Services Azure Files effectively was the same as being able to SMB mount a file system like a Windows Samba share. What file share backup and snapshots gives us is the ability to schedule backups of that file share natively through Azure, because otherwise what we were relying on was some form of third-party service or some form of backups process that we took snapshots of all our files. So what this allows us to do is to go, hey, I want to back up all of these at a particular time. You can configure that in the Azure portal, and it ends up in a backup service vault. So it's pretty sort of cool feature. Zone-to-zone DR is very interesting, and I'm still getting my head around this one. Azure regions, now they say that there are different zones in Azure regions, but these are generally not made visible to the end users, unlike AWS. So when we deploy a virtual network and a subnet inside an Azure region, it's supposed to go across multiple zones. The same with storage. If you do it, and if you do zone redundant storage or something like that, it puts it inside multiple zones inside the same region. If you spin up virtual machines inside a availability set, you can then specify in which zones you want your multiple virtual machines to go into. But you didn't actually see which availability zone it was in. Now, this is an interesting solution when you're talking about virtual machines that you're not deploying inside availability set. So if you've got something like, a database server or something where you've just got a single server that you're going to deploy, and it can't be deployed inside an availability set. The traditional method of DR was to have a secondary region configured somewhere with a backup vault, and we would restore this VM into the second region if the primary region went down. What this allows you to do is to deploy that virtual machine inside a different zone inside the same region. So I think it's almost like, from what I gather, it's almost like Microsoft making the zones more visible to customers. And what this does is effectively you can reuse your IPs and your subnets and your firewalls, because if a zone goes down, you just recover your virtual machine into a different zone inside the same region, attach the same public IP address and NSG that you had with it, and off you go. So that it reduces your risk and the complexity of bringing up a virtual machine inside a secondary region in this case.
Yeah, and a note that you're not going to get this in Australia, at least until we have AZs available in Sydney, in the Australia East zone.
Yeah. I don't think this is in Australia yet at all. But another one coming about Microsoft announcing their next generation VMware solution, effectively making VMware a first-class service inside Azure. So what this means is that you can treat Azure almost like an extension of your existing data center and then span your VMware stack across onto Azure. So if you're using things, any sorts of VMware tools like vMotion or vCenter or anything like that, you can use that to manage your workloads across Azure, and also use things like your hybrid benefit pricing inside Azure for running those virtual machines. So I'm not an expert on VMware, at least
Yeah,
in its
AWS had
format
the same,
now.
yeah, AWS had the same solution for some time now.
Yeah.
And then Azure around the same time introduced a similar solution, but with a third party. I think it was Cloud Simple. And
That's right. Yeah.
yeah,
Which got bought over by Google, I think.
yeah.
Yeah.
So because of that, now Microsoft, they've come up with their own solution working closely with VMware. So for VMware, I think this is about survival so that people will still utilize their services even on the cloud. Microsoft, it becomes another good chance to eat into that market as well, and then bring all those people onto Azure. So I think both parties are benefiting out of this. That's the same deal with AWS.
Yeah. No, it's very interesting. And the last one I had was the New Zealand region. Now I haven't seen an official Microsoft announcement on this, but I've just seen it in a couple of the IT news channels where Microsoft has effectively requested, I guess, permission to build a region in Azure. Now we don't know whether this is going to be a region pair or if it's going to be a single region, and what the paired region is, whether they're going to be looking at pairing it with something inside Australia. But I think it's going to be a good thing, especially for people who've got any sort of data center requirements where they've got to store stuff inside New Zealand, and also if you want any sort of latency issues, if you're running direct connect or something like that in New Zealand. So yeah, that's all I had from the news. I'll hand over to Venura to go his Pulumi demo, unless anyone's got any questions or wants to discuss any other stuff.
Yeah, I think there's a question. Are we recording this? We are recording this, and we will probably share the link after we have the session. And yeah, on top of what you had, Phil, I would like to add the PITR backups for Cosmos DB becoming available.
Yes.
Which is something interesting.
Yeah, because that was a big problem, right? You just could not back up Cosmos DB unless you dumped it to a file somewhere.
Yep. So they've finally made that a reality, which is good to see. And there's private link that went GA for storage accounts, which is something new as well.
Yep.
And the Azure VM image builder, I think there'll be certain people who are interested in hearing this, because now this goes GA on Q3 2020. What this allows is you can pretty much bake all your gold images into Azure rather than having it outside or have another means of managing them, because you can just use ARM templates to build them out and then keep them in there. So all the security people on this call, this will appeal to you. Yeah, I think that's probably it in terms of the additional things that I wanted to add. Let's get into Pulumi. Let me share my screen and start. I'll try to minimize my movements so you don't hear a lot of noise from my mouse movements. All right. If you have any questions, just don't hesitate, just ask straight up. I don't think we need to wait till the end. Please go ahead and stop me to ask the questions. All right. I think a lot of guys on this call know who I am. And for those who don't know who I am, I think I have been in DevOps for some time and then moved on to architecture and then jumped on to become a practice lead for Azure. And my day-to-day job is generally related to Azure, but I'm not a developer nor a DevOps guy. So um, my presentation will be a little bit different from a core DevOps person doing it, but it'll be more of a solution architect doing a bit of DevOps. All right. What I'll be doing is I'll be answering a few what questions as a part of this, and then I'll run into some basics and CLI. That'll probably be on GitHub, looking at some GitHub pages rather than being on slides, and then the actual code. And if we have some time, we'll look at how to automate this as well. All right, the first what is Git flow? So the intention here is that there can be certain guys who are just starting in DevOps. There are pros here as well. So just to ensure that everyone is aware of it. So Git flow is pretty much where you have multiple branches, allowing the developers to work on different branches. And then there are pull requests and other mechanisms that's bundled along with Git that allows you to test things properly. So you have your develop branch, which gets deployed onto your development environment. And only once it's stable, it'll move up to the main release and master branches. So this is probably a very complex version of the Git flow, but most organizations just have a develop branch and a master branch. That's about it. And then they branch it off, develop, make the changes, create a pull request back onto develop. And then once develop is stable and tested, the pull request goes back onto master. Moving on to the next one. What is infrastructure as code? So again, I covered Git flow because you needed Git to store your infrastructure as code. So with infrastructure as code, you have Git flow in play. Similarly to your standard development life cycles, you use Git flow to manage your infrastructure. Your infrastructure is written in some form of code. It can be your PowerShell, it can be your Bash, it can be YAML, JSON, or it can use any of those SDKs, the Python SDK, the .NET SDK. And then one of the APIs, well, Azure has one API, which is the ARM API. Those are generally the native forms of infrastructure. And then you have Terraform and Pulumi. Terraform and Pulumi are similar in certain ways. The main difference with Pulumi is Pulumi allows you to use a development programming language rather than using something like HCL, which is HashiCorp configuration language, which is really specific native. It's proprietary to HashiCorp rather than a native programming language. So that's probably the key difference. And then you define your infrastructure inside some sort of a language. And then how do you branch it off into your environments? Well, you have configuration or parameter files, which distinguishes your individual environments. What's next? Well, you follow Git flow. Master goes into production, hopefully, and features probably end up in one of your developer environments. And you have your orchestration. I think I have to move this away.
Yeah, Benura, you're on presenter view to us. I sent you a message earlier.
Okay, I have to change that. Give me a second. Back on the correct view.
We can see your slides now.
Awesome.
Yay. Yep. That's what we're supposed to see.
Sorry about that. All right. Yeah, this is where I was. So you've got your infrastructure definition. And then how do you branch it off into your different environments is obviously to have your parameters defining, well, parameters distinguishing your environments. And then you have Git flow. So Git flow will flow into master and feature. So probably master will end up in your production, and feature will end up in your development branches, development environments. And then comes orchestration. So you'll probably have to use a tooling like GitHub Actions. It can be Azure DevOps. It can be anything that's under the vast list of automation tools. And once you have the orchestration done, you've got your Azure stacks, your devs, your productions, la-di-da-di-da. But the idea of infrastructure as code is pretty much that you have it in code, and then you version control it the same way as you would version control your source code of your application. All right, what is Pulumi? Pulumi, they call it a modern infrastructure as code platform, but well, it is the same thing, but it's very similar to Terraform, but you just use your version controlling. And then it has a CLI of its own, a runtime, the libraries, and a hosted service, just like some of the other third-party services where it manages the state for you in their hosted service. You can always manage it by yourself on your local file system or a file share, or it can be even on storage bucket. Well, it can be a S3 bucket or a Azure Storage account or the Google equivalent. In terms of the languages, it supports TypeScript, JavaScript, Python, Go, as well as .NET. So Node.js, I think JavaScript, TypeScript, and any other Node.js compatible language will work. For Python, it has to be 3.6 or above version. .NET Core, again, C#, F#, and the whole suite going up to Visual Basic with .NET Core 3.1 or greater. Go, I'm not a Go fan, but what they're saying is statically compile Go binaries. I don't know what that exactly means. But that's what we have in terms of language support. So the same thing I've just said. So which provider? So they are supporting a lot of providers. If you look at the core providers, you've got Azure, AWS, GCP, and Kube. And then they've got a number of additional cloud providers. And then it goes into other infrastructure, databases, monitoring, network, and version control. Like if you look at this list, you can see that you can actually tie in a lot more things with your infrastructure just using Pulumi. It's not just infrastructure as code, but it has few other things that goes in line with it. And they've got a policy feature that they've introduced recently, but I haven't gone a lot into it. But what it does is it pretty much acts in a similar way to Azure policy. But why it applies is at the stack level, so or the project level. So it just doesn't work in Azure level, but it works at the Pulumi stack level. So this is a comparison that I did looking at what we have in play for infrastructure as code for Azure. I've looked at ARM templates, I've looked at Terraform, API, SDK, Pulumi, and CLI. This is purely my view. It's not absolutely correct, but and can be challenged. As far as I see, ARM is probably the native offering, and it has to be utilized as much as possible. And yes, ARM has its own challenges when it comes to modularization because of how they've structured it, but in general, the other factors are other features are really good with ARM. And then getting into, if you look at all these columns, frequency of updates, ARM API and the SDKs are at a higher level, whereas Terraform and Pulumi always has to wait for APIs to get updated and for them to release new features. Community-wise, again, Pulumi is at the lowest level in terms of how many people are using. ARM and all the other tooling has more community and more people who are looking at it. Infrastructure sizes, again, Terraform and Pulumi, I think can handle more complex infrastructure because of how it's structured, because you can modularize it really well. Whereas ARM, well, you can modularize it. ARM's got most of the tooling that these guys have now. It has what if, it has syntax checking that they've released recently, and a few other things. Yeah, I'm just doing comparison with different things. And then the tooling again, yeah, tooling probably is higher with Terraform and Pulumi. And state management is the next thing that we have. ARM has state management, but it's within the Azure portal. Terraform and Pulumi has their own state management platform, and you need to ensure that you manage it properly.
Vinod, do you know if Pulumi uses the API or the CLI or ARM in the back end to talk to Azure?
So
APIs, is it?
both Terraform and Pulumi is using the APIs.
And that's probably how they're doing the state management as well then.
Correct.
Yeah, okay, cool.
For stack management, I think again, Pulumi and Terraform has a concept called stacks, whereas any of the others don't have. Well, you can come up with a stack management of your own, but that's going to be hard. Modularization, I think I touched on that. ARM has a bit of a difficult situation with how they've structured things. So it's always that you have to have something outside and a public URL to have your modularized content. So that's about it. And languages, I think we've touched base. Pulumi obviously has the advantage of many languages as well as the SDK. Yeah, this is something we shouldn't be dwelling on too much. And let's get into getting started.
Sorry, can I ask? This is Sunil here.
Yeah,
if you went back to the previous slide, and you were starting automation, and you've had a choice between what you have up on screen. How would you? I'm assuming you've not ordered this, right? It's not ARM's one of the best, and then Terraform and API. So, if I were to choose your recommendations here, like at obviously every organization is different, but what would you recommend? Like, where would Pulumi sit? Why would I choose Pulumi over something else? What have you sensed about Pulumi? I'm not sure if that, it's just more of a prompt to you, but what's your general, right?
Correct. So Pulumi is an alternative to Terraform. And there are many organizations who are using Terraform to manage their infrastructure. The main reasoning behind using Terraform is that you have the same stack managing everything. It manages your AWS, it manages your Azure, and it manages your on-premise as well. So the alternative that Pulumi brings in is that you're not using a Terraform native language, which is HCL. So if you're using Terraform, you need to learn HCL and you should be writing HCL. Whereas Pulumi just gives you additional options where you can get your development teams to get into the infrastructure as code rather than having people who just know infrastructure. That's probably the only advantage that Pulumi brings in. Pulumi, obviously, it has a lower number of customers compared to Terraform. So it might have some issues to start with, but I think it'll pick up over time, and it's always good to see how it works and also understand the concepts in there, because you never know how the community works. Today it's Terraform, tomorrow it's Pulumi. They all behave in a similar way.
Yeah.
And
sorry, and I think if you're on one cloud, I think you should use whatever that cloud's tool set.
Correct.
But if you're going across multi-cloud and then you want to have some form of, I guess, similarity in your tooling and your controls, it's probably, in this case, it's probably a choice between Terraform and Pulumi. And if you've got, because just by looking at the feature set, if you want to use HCL, then you go Terraform. But if you want to use if you want a combination of any of the other sort of languages, you probably would lean towards Pulumi. and it might be even almost a commercials and it's maybe a feature comparison on other things between these two if you're going with multi-cloud. And that's my gut feeling on these two.
Correct.
And just, one more before I went around, before you go to the next. How's the knowledge base with Pulumi? Is it easy? There's a lot of articles. Is easy to understand?
It is easy to understand because if you're a developer, it is easy to understand. I'll put it that way.
Yeah.
And the community is actually good. So once you register with them, they normally add you to their Slack channel. And if you have a question, you can just go in and ask straight up because it's a smaller community. And you generally get an answer within 5 to 10 minutes. So it's quite good if anyone's doing stuff on Pulumi. And everyone is quite quick to grasp onto bugs or issues that's in there. So I found a bug when I was playing with this, and they agreed, look, there's an issue, we'll look at it. And then there was always a workaround how you should just change your code to not have that.
All right, thanks, guys.
All right, jumping on. So getting started with Pulumi is quite easy. They've got everything documented, so it'll just walk you through this, walk you through steps, and you can just install and get yourself set on there. If you're on a Mac, just smash brew install Pulumi, and if you're on a Linux, that's probably what you need to run on your computer. And then you need Python, and then you need to log into Azure. So AZ login, Pulumi honors AZ login, but only when you're using your Azure credentials. But for some reason, if you're using Service Principal, it will not work, and you need to set some environment variables for it to work. And then just go Pulumi new, and you have your new project. So hopefully this won't go wrong, and it'll work. Enough slides. Let's jump on to an actual demonstration of how this works. So,
hey, Vinira, I had a question, sorry. So you said it doesn't work with service principals, is that right?
it works with service principals, but for you to get it to work with service principals, you need to set 4 environment variables. So I'll get to it when we have a look at it.
Yep.
So if I go into my play area, so this we covered. I think they've got, I've got it in GitHub pages as well. So if you want to start it up, just look into my repository and you'll have most of the information in there. So this is more on installing the Lingo. They have a program, which is the collection of files written in a chosen programming language. And then there's the project. Project is pretty much a directory. And as long as you have a file called pulumi.yaml, that constitutes a project. And then the stacks. Stacks are obviously instances of your project. So if you want to just play around with my project, just click on this button and it'll actually take you. If you have a Pulumi account, obviously you need to register in there. It'll straight away take you in there and it'll ask you to deploy all of this. So I've just given it a name because I have that name, it's complaining, but if I just give to do one, it will just deploy it straight into your environment. So that's how you deploy this project. But for new projects, you can either use the new project web app or just use Pulumi new. And the third way of creating a new project is actually to have a Pulumi YAML inside your folder. So what Pulumi new actually does is it just creates all these things. It just gives you some prompts, you answer the questions, and it does the same thing. So have the pulumi.yaml file in there with a name, which will be the name for your project, the runtime that you're going to use, and a small description. And the moment you do that, it'll just go and create it inside Pulumi. So if the area that you can check this is app.pulumi.com, because app.pulumi.com actually manages your state. And if I go into this, stacks, there you go. So it just lists your stacks in there. Why is it not taking me to the other view? There you go. So it shows your project and then the two stacks that you have deployed on that one. So the first thing you have to do is that you need to set up Pulumi. To set up Pulumi, you need to hit Pulumi login. And if you have Pulumi access token, which you can get from your settings, just go in there and request for a new access token. As a part of your environment variables, all you need to do is just do Pulumi login. And if you don't have that, it'll prompt you to enter your token and it'll still work. Enterprise customers, obviously you've got your different URL, which you need to log in. So you have to make sure that you explicitly pass that URL. You can use your local file system, either with a file path, or if you just say local, it'll use your home directory. The other options are to use Azure Blob or the other storage containers available as a part of any of the other hyperclouds. So now you've got your Pulumi set up. And what happens is if you go Pulumi login, there you go. So it says I'm logged in as Venura, and this is my instance. Running the app, you can either initialize a new stack. So as a part of the initialization, what it does is it will ask you to do certain things. So if we try this out, I have dev. So if I just go with test, it'll create the stack, but it will not have the other required parameter files. So for example, the environment specific parameters are in dev.yaml. So it'll ask you to create those files. It'll ask you to pass those parameters at runtime, or you'll have to set them. So the other way is actually to use the switch command. So the difference between the two commands is now I've used the command and assume I'm trying to automate this. And if I try the same command, it'll error out. But with the switch command, you're actually trying to switch to a stack, but you're saying if it's not there, sorry, test. If it's not there, create it. But if it's there, just did I just have the wrong? Stack, not switch, actually, it's change. Select. Test. See. There you go. So it'll still do the same thing, but it's a bit different because you can keep on repeating the same command. So it's handy when you do some automation, but if you're just running it from your CLI, there's no difference. So if you go Pulumi stack ls, it'll list all the stacks now. There you go. So the new stack is available. And obviously you need to do AZ login. I've already done my AZ login, so I'm not going to do that. And then these guys just want you to do virtual environments. It's not really important if there are no other projects with dependencies. But if you have dependencies, yes, you need to use this. And then you can just do a pip install to pull all the requirements. So the requirements txt, you need to define what you need in your project. So if you go in here, your requirements txt will tell you're using all these Pulumi packages. So this is just a Python thing to pull all the required packages. And then you have a Pulumi YAML. So you actually don't need to define anything if you have this for this project, it'll automatically pick it up and it'll automatically get the stacks as well. So let's wait for this to complete. I should have actually not done this, but that's fine. So while we wait for this to complete, there are two Azure specific parameters that you need to pass along with this, which is which cloud you're using. So we're using the public Azure environment, and then which region. So either you can do config set, or you can create the Pulumi configuration file. And then as a part of that, you can have them defined as well. So what I'm going to do is now just pass these two in there. And what actually happens is if you do an ls, it'll have the test YAML created. So if you go back here, it's got these two values. So the other two values that you can do is the SQL username. Let's call it Pulumi. So you can always pass this as a part of your automation, your DevOps tooling. Just run these commands and they'll get set. There you go. And then the password. Just call it admin@123. There you go. So it'll be stored as a secret. And then we'll switch back to we'll switch to another stack. Dev stack is the one that I was using. So now you can do Pulumi preview. What Pulumi preview will do is it'll show you if there are any changes. There you go, so no changes. But if you now switch to the test stack and do a preview, it'll actually pick up all those 7 changes. There you go. Now, if you want to create this infrastructure, just go Pulumi up. And then if you go to the Azure portal, you'll see that this will start getting created. Sorry, you need to say yes. So API actually has a bit of a delay for things to start, even though it reports saying, yes, it's done from my end. So Pulumi is saying actually this is created. It takes, there you go, a little bit of time for this to get created. So I'll get to how the code works in a bit. Sorry, I'll get to how the code works in a bit, but for now, let's look at our dev environment. That's all been created. So we had a bit of a path stack in here. So while this gets created, we'll go through the rest of it. So there's Pulumi up, and then that's just printing the endpoint. So there can be situations where people just go in and change stuff in the portal itself. Well, if that happens, you can use Pulumi refresh and Pulumi preview to do that. So Pulumi refresh will pull all the changes through the APIs and then update your state. And then you can just do a preview and fix diff. But look, generally you shouldn't be doing this, but if anyone does it, that's something you need to have. You can potentially have as a part of your pipeline. So that is pretty much Pulumi. And going to your source code, all you need is a Pulumi YAML, which explains how it just gives the metadata about the project. And then for each environment, you need to have your environment specific YAML file. And then main.py is just your file that describes all your infrastructure as code. Requirements is just a Python thing. So if you look at what the actual infrastructure as code contains, it imports a few libraries and then it gets what the stack is. So the stack name, the project name, and I'm just using that for the naming standard. So you'll see that the application name, the environment name will be everywhere in the naming. And then it's just a matter of passing these parameters. The resource group you create initially, and then you can use the same resource group across everything. So there you go, resource group is resource group name. So this gets passed on to each of these resources to ensure that they all get spun up inside that one. And one of the bugs that I found out, for example, with them is for application insights, if you don't specify the retention in days, it actually defaults to 90, but the state doesn't get updated. So every time you run the Pulumi preview, it actually goes, yeah, there's a new change. So I couldn't figure it out until someone from the community told me, look, there's a bug. If you specify it explicitly, it works. But if you don't specify it, the state is in a bit of a weird state. And the other thing is you can, so this picks up the location from one of these ones. If you don't specify it, but also you can specify. And the naming wise, something that I noticed with this is that it actually adds a random number at the end of all the resources. So you can not do this by specifying the name explicitly, but if you don't specify the name explicitly inside this stack, well, this function itself as name, it'll add the auto numbering in there.
Is there a way to get dependencies from resources that are not part of this stack? So for example, if you want to pull out a key from a storage account from something else that is not part of this stack. I've got a storage account that is in a different resource group deployed completely separately, but I want to use its key, for example, as an app setting somewhere. Is there a way to do that, or are you tied down to what's inside this?
From what I played with, I think you're tied down to the stack. You can't go outside, but I may be. So
like even things like key vaulting, I think it might be if you have a central key vault that you need, to pull credentials or something into this.
You can back your credential storage. So right now it's just using the Pulumi's engine, but you can always back your credentials use a key vault or an equivalent on any of the other clouds. So there's a config that you need to do. Right,
but that's purely for credential, isn't it? You can't like pull out, you haven't seen being able to like pull out an IP address or something else from a resource that's outside of this for your configuration.
I haven't gone to that far, but probably.
Yeah, it is possible.
Cool. Yeah, thanks, Matt.
So you can refer to another stack. There's a concept called stack reference, and you can also you can import resources that have been provisioned already in the portal or using the CLI or something else. You can import them by specifying a unique ID that they've got.
Oh, excellent. Thanks, James.
There you go. Yeah, that's pretty much it in terms of my high level playing with Pulumi. And the other thing that I tried out with these guys is to automate. So if I look at my workflow, this is completely wrong. I'm using the master branch to deploy a development environment. But this is my attempt of automating something in there. So the challenges that I had was pretty much passing these ones. And yeah, you can just run all these commands in one go, but then you need it to be inside the virtual environment. And then you need to pass the Pulumi access token, the client ID, the client secret, the tenant ID, and the subscription ID all. as a part of environment variables for this to work. I think I spent a lot of time just playing, changing, getting it to work. It never really honored anything to do with AZ login as well. But this is probably an older stack, and this probably will have my bug as well. But then why I did this was I thought, well, Pulumi is saying this, and maybe that's not right. Maybe I can do it a little bit differently, because what they're saying is you need to use the Docker image. Well, Docker image takes a bit of time to come up. So I thought maybe just use standard stuff and see if it works. It works. But if you look at how they've done it, they're doing the same thing. They're defining all the environment variables anyways. But the Docker image does all these things in one go and just do it for you. You don't need to worry about any of this.
So there isn't an extension, is there? You've got to use either the Docker image or you've got to run Python.
Correct. You got to run Python and play around with it a little bit to get it working, which is not so great. I haven't tried any of the other CI/CD tools, but just GitHub Actions. So if I look at one of the runs, maybe we can just rerun one of these runs. There you go. Checks out, install pip, install Pulumi. So all these things are done by the Docker image. We don't need to do any of this. Flake8, I think I have some naughty code in there, which we will ignore. And just runs all those commands in sequence, and there you go. So this was actually the buggy code that's still in there. So I haven't done a push. Let's do a push and see. Right now it's picking up a few changes. So git status. Up. But I haven't added git and sign it. Pushed and see if it works. So this time, ideally, it should tell me that there's no change because I'll put the workaround in place. Let's wait for the action to get triggered. Seems to be misbehaving. Let's just give it a bit of a refresh.
You haven't done enough sacrifices, Venera.
Probably. Well, at least the demo didn't fail, so it's good. And everything just worked. There you go, 7 unchanged. Did it say that? Yeah, preview the stack.
7 unchanged, yeah.
Yeah, 7 unchanged. So There you go. So all of this is in my repo if you want to play around with it or create a pull request or make any changes of my bad code. This was probably my first attempt because I don't know anything to do with Terraform. If you ask me what Terraform is, I'll go, yeah, it uses a state and that's about it. And this was probably an eye-opener in many ways because there were certain good things that ARM templates didn't have as a part of Pulumi. But still, personally, I would still use ARM templates if I'm just doing Azure. The main reasons are this one is a little bit towards the buggy side, and also it's maturing. But once they mature, maybe in another 6 months, I think it's worthwhile going ahead with Pulumi. I know that there are certain organizations in Melbourne also who are looking at using it in production. And I saw a few people in the Pulumi community as well, the Slack channel from Melbourne making some comments. So probably there are people, and there may be someone on this channel as well. So if there is, I think that's a good thing. We can know whether it's actually viable to use. Because Sunil had a question. Maybe Sunil is going to use it.
Maybe. You never know.
Venera, how would this be useful if you have multi-cloud? Like what advantage does this bring? Like the same code or?
It's never going to be the same code. So it's a dream, to be honest. Everyone just paints the picture as if, no, you don't need to change anything. No, it's not correct. But you're using the same tooling. You're using the same programming language to do it. And then there are similarities in how you operate. Mm-hmm. But there's no such thing as I can write a piece of code which will work on all the clouds magically. Then you're generalizing that deployment so much that then you just lose the value of having a public cloud.
I guess you could consider modularization, taking it somewhere down that path.
Correct.
But all you're doing is really hiding the complexity. That's my gut feeling anyway.
Mm-hmm.
Because you're just abstracting what a virtual machine looks like on the two clouds. Someone still needs to define what a VM looks like in Azure and what a VM looks like in AWS and what it looks like in GCP, I guess. The other thing, Venera, you probably didn't cover in this was, does this have modules like Terraform? Can you do modularization or?
I intentionally didn't cover that, hoping someone will ask that question. So why would you need modules? You're using Python. And you can write Python modules. You can just add more and more in there. Yes, Terraform does modules because Terraform is not a real programming language.
Yeah, I guess so. Yeah, I think I need to play with it a bit more. But I think it'll be nice if I can just say if I can define what a virtual machine looks like somewhere, and then
you can do that. What you have to do is just include another Python file that is a module, and then you can just import it onto your main.
So it is still kind of the same thing, isn't it?
Yes.
Which is probably not. I mean, you could probably do similar with linked ARM templates if you really want to, or nested templates.
Yeah,
but I find modularization a cleaner way of doing it.
Having it on a public place where ARM can access and all that. I think that's where ARM is a little bit behind, but apart from that, ARM's way better.
Well, I guess that and state.
And the state, and also the fact that you're using JSON, because the same infrastructure which I had over here, if you're writing it in an ARM template, you're looking at 1,000 lines. I don't know, not 1,000 lines, maybe 500 lines.
Yeah.
A lot more lines than this. You need to define so many things. So that's probably where ARM falls behind. The state is one thing, and the other stuff as well. And I don't know whether you have noticed that it's not going to leave any deployment history. This is failure anomalies, but the actual deployment is using the APIs.
Oh, yeah. But that's the same as if you use the Azure CLI, isn't it? Azure CLI or Azure SDK to connect onto it?
SDK. CLI sometimes leaves certain components, but it's a very messy way of doing it. I don't know how the CLI works. But the only component that will leave an entry here is ARM generally.
How about the activity log? Does that tell you anything?
It should tell you. Otherwise, there's a big problem. There you go.
Oh, there you go. Yep. Yep.
It picks up all the changes. Activity log does pick up all the changes.
Because I think deployments are effectively purely an ARM thing, isn't it? And the activity log actually gives you the JSON as well and the change preview. No.
Let's check in there and see if we get something in there. Yeah, it was, there you go.
So it gives you the JSON, but no, that's just the, okay.
Yeah, it's not the same. So you can pull what the resource is from the Resource Explorer, but it's never the ARM template. So that's probably the thing that we need to be wary of. So you need to manage the state properly. If you lose the state, you lose it.
Yeah.
Any other questions, everyone?
Could you go back into that into the activity log window? I saw the state preview thing. I'm not sure if that's still. If you clicked on the high level deployment, the update website one, the first one.
Yeah, there were some questions.
Change preview, change history.
It just compares the two. It's a comparison between what you get out of.
Okay.
So there are a few questions. If you're writing, let's quickly go up. Mike is asking about the dependency, so we've got the answer.
We covered that. I think from what I've been monitoring on this conversation, we've covered up all the questions that was asked.
Yeah, James, thanks for replying to most of the questions. Yeah, I think we're done, everybody. If there are no questions.
Excellent.
Veneron, quick question.
Yeah.
How is governance and security baked, or how are we adopting to this?
So governance and security, there's a separate Pulumi module that they call it CrossGuard.
Okay.
And it is a policy engine. So you can pretty much use this to define your policies. The same way that you use Azure policy, you can use this to specify it against a certain project. So
is it at a project, or can you define it at an environment level or at a stack level? For example, for dev, can you say you can't spin up any type of virtual machine for dev, or would you be relying on Azure policies for that sort of stuff?
I don't think it'll do Azure policy. It's their own policy. So if you go up, this is authoring. James, have you used the policy component with this?
He's put a comment in there, and I think he said, I think Pulumi is just for the CLI for now, but they're working on that.
There you go.
Oh, sorry, that was for the API. Sorry, that was wrong. Wrong question.
Yeah, no, that wasn't about policy. That was answering the question just above about whether you can, I think, programmatically trigger Pulumi.
Okay, cool. Yeah, so have you played with the policy engine, or is there anything that you can add on top of this one, because this question popped up?
I've had a look at it. I haven't implemented it yet, but I think the important part about it is it is still multi-cloud. You know, it's cross-cloud. I think they're working on AWS first, but eventually you'll be able to write policy that is, you know, for your organization rather than being specific to a particular cloud provider.
Okay, so is this similar to Terraform Sentinel?
Yeah, I think it probably is. Yeah.
Cool, cool. So James, are you using this in production, or are you looking at this?
Yeah, I was looking at it privately. I am looking at it. I'm working with. I learned Python at the same time as Pulumi, so it was interesting. But it definitely solved the problem for me, because in a job I was doing, I found that our way of implementing like a landing zone in Azure wasn't controlled enough. We had PowerShell and we had, you know, scripts and things, but you didn't have enough control over anything. And then there was no infrastructure as code concept to it. You know, so that was not Pulumi, that was the system we were using, right? And we knew it wasn't satisfactory. Someone had tried Terraform and sort of got halfway there, but found it was all too hard and they couldn't quite get it to work. And I decided to give Pulumi a go, and I just found everything clicks. It's just, you know, once you've worked out, you know, Python and Pulumi and got your head around the concepts, suddenly you can do anything. So that's what I found was good.
That's interesting. That's great to hear. So when you said you set up a landing zone, is it the standard CAF landing zone that Microsoft promotes?
It was actually just the exact landing zone that I was trying to implement as part of the business. You can see it. I've contributed to Pulumi.com, so you can just look at their examples. So github.com/ yeah. Yeah, that's it. And if you go and if you scroll down in the list, Azure-Pi-Virtual Data Center.
Okay.
Yeah, this one here. So that's the end result of what I worked on since January.
Okay.
And what I liked about it is, you know, obviously you can see that I was learning Python as I went, but this is the top level file, and it basically is very expressive. You can see that exactly what you're doing is you're creating a, just go back into main.py.
Okay.
You know, you create the resource group in line 10, you create the hub in line 13, and then you create a spoke in line 32 and another spoke in line 47.
Yeah, cool.
And it's minimal in the sense that you only need to specify what you need in that top level code. It's very concise.
It is. It's saving a lot of time. So I'm just interested to see how your hub looks like.
Sure.
You got express route in here?
Yeah. So the routing was the most important part of it. And what I could do there was, because it's Python, I can do all kinds of stuff with IP addresses and the actual custom routing. I could use it like effectively like a table and iterate through that table to produce the routes.
Yeah, loops using ARM is funky, isn't it? Conditional loops using ARM is very, very annoying.
Oh, that's scary. I couldn't get my head around it. Whereas this,
I
just came naturally.
I think I had to do one, and I had to then output JSON as text or some weird thing, and then convert that back again.
Yeah. So if you see those routes there, you were just looking at the routes before.
Yeah.
It's interesting as well that you were talking about the stack reference, right? So if you come down a little bit, what I can do is once I've built this hub and spoke in, say, Azure East, Australia East, I can build the exact same thing in Australia Southeast, and then I can peer the two hubs, which is what happens further down. Bit further down, I think. These are the ones. This is the routes within the hub. Yeah, so this VNet peering between stacks using stack reference. So that's basically saying that you pass in through your configuration the fact that you want to peer another stack by giving the identity of the stack.
Okay.
And it goes and looks up the details it needs from that stack. So wherever you see get output, you've got get output hub ID. Bit below, you've got get output for 3 other parameters. And then it just uses those parameters to construct routes.
Interesting. It's really nice.
Much nicer than ARM. Yeah.
Much nicer than ARM.
And what I liked about it was you're actually writing code. You're actually writing software. You're not writing this You're not writing a configuration file like YAML or JSON, or you're actually using the features of the programming language to be able to do things more expressively, to be able to see that, where you're doing the routes. I can use a loop to go through that table of routes and implement them all. And then when you can look at that table, you can see the entire thing there, and you can say, right, that's complete. I can see from the symmetry in it that tells the whole story.
Just out of curiosity, James, would you consider writing this using the .NET SDK or something like that?
Yeah, I mean, I also, while I was doing this project, I got involved with another COVID-19 project, and that was in AWS, and it used a desktop client, but they wanted to run some infrastructure in AWS, and they were using C#. So I said, okay, well, I'll use C# as well, and I did in one day, I managed to write some Pulumi code to implement their just an open source video server in Azure using C#. So I'm also learning C# at the same time. I didn't really know what I was doing, but it's effective. And what I found as I was writing this particular piece was I started out initially with just like one file. And you can see if you go back up to the directory above that eventually it automatically resolved into a number of files, right? So you can see that you've now got the main.py, which is where I started, but then I peeled out configuration into its own file, and the hub into its own file, and the spoke into its own file. And then the VDC file you can see there, that's the only place where I actually call Pulumi code. So that's all been pushed to the back end. This is the Azure, effectively the Azure code that you call from Pulumi, and that's got all the details in it. And the only thing I've got in the other Python files is the absolute minimum that you need to send to this to execute the code. The parameters, effectively.
Nice.
There you go, Phil, your modularization question asked. He's just pulling all this.
Yeah.
From hubs.
Nice.
What you can see right there is this idea that Pulumi's got where you can build your own components. So effectively a hub and a spoke, they're aggregations of resources, but you can give them their own identity so that now you're talking about, instead of your hub being like a few, like spare parts flying in close formation, you've actually got a component called a hub that's got its own identity and it's got its own parameters, but it isn't provisioned separately. It's just like a collection.
It's almost like an object, isn't it?
Yeah.
Yeah. Very interesting.
Very interesting. So anyone else have questions for us or
comments, feedbacks?
Yeah.
So what was that?
Feedbacks, everything is appreciated. This was probably the first time Phil and I did a meetup. We've been looking at doing something like this for a long time. We are generally hands-on people who moved on to become architects. So we're somewhere in the middle. We're not really there, but we're not really here either. And
yeah, I think you and I have these conversations quite often during the week. So we thought it's probably a good idea to open it up to the floor.
So the whole idea was there's not much automation discussions going on in the Azure land. Yes, there is. There's like a plenty of meetups that have Azure or I think AWS is quite common, but nothing specifically looking at automation. So we thought we'll start it, but then we'll give everyone else an opportunity to come in and present. So the whole idea that is that everyone gets involved. If there's anyone else who's willing to put their hand up to become an organizer, we're just more than happy to make you an organizer and come in, present, help us. And
Yeah,
also
and if anyone's got anything they want to talk about, please reach out and we'll start something in for you.
Correct. All right, if there's nothing else, thank you everyone. And until next month, we have something lined up for you. I think Phil, are you planning to do something?
Yeah, I'll try and if I actually get the chance, I'll try and get something around MLOps in here about pushing automated machine learning models and something like that, if I can.
Cool. Awesome. All right then. Thanks everyone. We've it's 7:30. Hopefully we're on time.
Yeah, right on time, almost. Yeah.
Thanks, guys.
Cool. Thanks, guys. See you, everyone.
Thanks, guys. That was really
Thank you
good.
all.
Thanks.
Thank you both. That was very good.